Welcome to the studio at 50 Oliver Street. My name is Jason Daniels, Executive Director at Easton Community Access Television, and with me today is David Stephenson of Stephenson Strategies, one of the leading voices on IoT, or the Internet of Things. David, thanks for coming on.
Glad to be here, Jason.
All right, so I suppose maybe we should kick it off by at least telling me what is the Internet of Things for
Sure.
the general public.
Exactly. What it is, and it really is, I think, a transformative breakthrough. We can get more into that later on. But it's the idea of adding intelligence to things. One of my favorite examples of that is from a company not all that far from here in Needham called Big Belly. And you may have actually seen some of these on the streets. If you think about the old-fashioned municipal trash cans, just this wire frame thing that's just sitting there.
Yeah.
More often than not, it's on the side and a mess and the trash is falling out. Well, they've taken those and they've converted them to big solid devices that have solar compactors to compact the trash so you can get more in. Well, that would, all by itself, that would have been really neat.
Yeah.
But that's not an Internet of Things device. The Internet of Things device adds the element of data collection and communications. So one of the things that they thought about after a while was, hey, let's monitor with the compaction how full the container actually is right now. And that's another really important thing about it. You want to get the information right now, not after the fact. It's nice, to know a couple weeks after the fact what something was like, and that might have some value to you. But you really need that information right now. And so then they monitor that. They have devices in it that just do that automatically, and then it communicates back to the DPW so that they can actually schedule the pickups based on when they're really needed. And then there's another component to it. Years ago, you and I collaborated on a series of public service announcements about bringing personal technology to Homeland Security.
Right.
And one of those was about what are called mesh networks. Those are self-forming networks. You don't have to have an administrator. They just automatically form out of any of the nearby devices that are enabled for the thing. Guess what? You could actually have, in a place like Boston, where there are a lot of the big bellies now on the street corners, in a disaster, you could have a network that would spread emergency information simply formed out of these trash cans. Who ever heard of something like that? So
Really?
it's absolutely amazing the stuff that you can take and add intelligence to them.
All right.
And it just
could I stop you there?
transforms. Yeah.
So, in this case, how do you define intelligence?
Intelligence in this case is being able to harvest real-time data about how something is working or not working in some cases, and then being able to relay that back to whoever made it, the distributors, the retailers, all the designers. They're very important to the whole thing. And we've never been able to do that. I talk a lot in the book I just wrote that's going to be out in August about IoT, about what I call collective blindness, which affected, pardon me, just learning your language. It afflicted every single human being. And what collective blindness meant was that when there was a big device of any sort, didn't matter what it was, all we could see was the surface of the thing. We had no idea how it was actually operating or anything of that kind of sort. And as a result of it, we were pretty clever people, so we came up with workarounds to deal with that absence of information. But more often than not, they were just hunches. And now that collective blindness has been lifted, and we actually can see inside of things figuratively with this real-time data collected by the sensors. what is really happening with it. And that really transforms everything.
Right. So I think I heard the kids in the background doing a video club. Just in case anyone's wondering why there are children yelling in the background. But let me just go a step further here
Sure.
and ask you. So with this data that's being sent
Yep.
to a company or a business or I don't know, government entities as well, municipal entities, the information, how is it traveling? Is it a public Wi-Fi? Is it a dedicated private network? How does the information travel?
More often, it's wireless. There are some, particularly with company things, with manufacturing and all
Right.
of that, where it does go over wired communications, a little more secure. But otherwise, it is wireless. And that, incidentally, leads to one of the big concerns about the whole thing, which is how secure is this information, particularly
Yeah.
because a lot of what we're getting into now are smart IoT devices that, for example, can monitor your health conditions. And nobody wants to risk that kind of information being intercepted. In writing about this, I have what I call 4 essential truths of the Internet of Things. One of them is sharing data rather than hoarding it. One of them is closing loops. So instead of linear processes, you have circular ones. One of it is rethinking the whole role of products and how they're designed. And what originally was my last one was making privacy and security a priority. And as I thought more about that, that's now the number one thing.
That's now the number one.
I'm convinced. I used to do corporate crisis management
Okay.
back in the 80s and 90s. And I used to work with Fortune 100 companies that had done stupid things, and their reputations, and in some cases even their survival, was hanging in the balance. And I had to work a lot with engineers on this, and I found that engineers were so linear in their thinking that they weren't very good in a crisis like this, and they particularly had a really, really hard time thinking about fear. And because they were able to pick apart very quickly the fact that a lot of the fears weren't really factually based, they were more perceptual. And I kept saying to them, guess what? The fact that it's more perceptual and may not even have a basis, in fact, doesn't mean it isn't real to them. And if they start to fear what you're doing, you are going to lose their confidence and you may never regain it. And I think that is a huge obstacle with the Internet of Things, that unless you can guarantee privacy and security, the whole industry, it's funny because there are all sorts of companies in this field. There are big, leading, extremely responsible ones, such as GE now, and a whole range of other ones. And then there are these fly-by-night startups from China that there was a massive attack on the internet in October of 2016 that was done, one of these denial of services things, where they specifically targeted IoT devices with little or no security. You know, it'd be things like a password, like password or 1234,
Right.
and other, absolutely ridiculous stuff like that. And it almost, not only did that risk the individuals' homes and, and their private information, but it also brought a large part of the internet to a screeching halt for part of a day. It was incredible.
Right. And that's kind of that's a reflection of how pervasive these technologies are right now. Let's take a step back and maybe give me a sense of where the Internet of Things began. What's the timeline for it?
Sure. There are a number of histories of the IoT, but the one I particularly choose to point to as the starting point was a group of students at Carnegie Mellon in, I believe it was the early 80s, who rigged up a closed-circuit TV thing, and I believe there was also a sensor in there for a critical thing. They wanted to make sure that if they went to the Coke vending machine in the dorm, that there would be Coke there. And so they had this system that they could monitor from their rooms. And from such humble origins, the Internet of Things was born. And then leap forward to the late 90s, and there was a guy named Kevin Ashton, who actually still is a leader in the field, who at that point was at MIT, and he developed the program that developed those RFID tags that are increasingly on a lot of individual products that have a simple but very important task, which is to locate where a specific thing is right now.
So what's an RFID tag?
It's one of the. It's like a barcode tag.
Okay.
Only it has additional information, and again, it can be shared wirelessly, and it's really important for logistics and supply chain management, stuff like that. And that's a really, really simple example of it. But if the Internet of Things had stopped with that, it still would have been really important, because in the past nobody knew where those things were. And so it's built on that. There are two other really important things that have come along since then that made it possible. One was the development of tiny and increasingly efficient from a power standpoint sensors that can detect the current status of the device, the temperature, vibration, all sorts of stuff like that. And then big data analysis like IBM Watson. And probably people have seen recently those new ads for Watson, where the repair guy goes to the front desk at the high rise and says, "I've come to repair the elevator." And the guy at the front desk said, "We didn't order that." And then you see the door on one of the elevators open, and there's the Watson logo and everything. And Watson says, "This elevator will fail in 2 days, and I have sent for help." And that's a really, really cool thing called predictive maintenance.
Predictive maintenance. Yeah, and I do want to touch on an example of that you had mentioned before. How did you personally find your way to the Internet of Things?
Sure. I was writing a book a couple of years ago called Data Dynamite about sharing data. And I just happened to come across a couple of examples of the IoT, and I parked those for later consideration after the fact. And I think the thing that really got me interested in it was that the Data Dynamite book, a critical factor that I kept emphasizing in that was the need to share data rather than hoard it. And in the past, it was a sort of a rule of business that the way to succeed was if you had data that I didn't have, you were a winner and I was a loser. And that really made sense for a long time, because data was so hard to gather and hard to disseminate and everything. And as a result, it was prudent business strategy to do that. And in fact, I think one of the obstacles that we have with the Internet of Things is that's still sort of ingrained in so many people. My favorite example of the old way of thinking was that in England in the 18th century, it was a crime to take the plans for one of the arc rate spinning mills out of England, because it gave the country this huge economic advantage. But there was no way to keep people from memorizing the plans.
Right.
So there was this kid named Sam Slater, I think he was 21 at the time, who worked in one of the mills in Manchester and memorized the plans, hopped a boat from Manchester to Rhode Island, and created the first spinning mill in the United States, in Pawtucket. And it showed that it's really hard to restrain the sharing of data. And now what's happening, this is so cool nowadays, the data actually becomes more valuable if it's shared. There's a wonderful website called if this, then that. And
so it's at IFT?
Yeah, IFTTT.
IFTTT.
Yeah. And what they do is that a lot of smart companies, Philips, the bulb company, and medical technology, GE, all sorts of others, now share the application programming interfaces for their smart devices with this site. And it's all done very cleverly so that people with no expertise can create what they call recipes. And the cool thing is, each one of these individual devices becomes more valuable because you have a lot of people like you and me with no technical expertise creating ways to capitalize them. It's amazing.
Right. So I think you just touched upon the API.
Yeah.
And I think that's a pretty important concept for people to understand how you start to get in touch with a toaster oven or something. So let's just stop on this idea of this API or application programming interface.
Yep. Exactly. Well, that really is the key to the thing, because it is what allows control of the device after you've manufactured it. And so sharing that rather than just, putting out a device, it might be very cool, the device you put out,
Sure,
with your particular app that is keyed to that. But I don't care how brilliant your engineers are. They could be incredible, but they can't possibly think of every conceivable use of something. And so when you start to share the APIs, and then also one of the things that's really neat is when you start to mash up the APIs from various devices, like for example with Siri, and I think Alexa has the same thing. If you have, say for example, with Siri, you can say, and the Apple HomeKit, you can say, Siri, it's time for bed. And when you say that single command, you're not having to command each one of the devices, your Schlage front door lock, your Philips Hue lights, and your Ecobee thermostat. With that one thing, just saying it's time for bed, they all turn off or down. And so one of the things that I think is cool about that is that by sharing that information, the devices from each one of these companies becomes more valuable than it would be in isolation from each other.
Right. And that is possible because of this idea that there are open APIs that these companies can sort of
now, and the
leverage, I guess, if you will.
Exactly. The downside is if you're sharing is you also are vulnerable to theft and the security breaches and things like that. So I don't care how great your initial device is, the privacy and security thing is a never-ending challenge.
Right.
You have to constantly be monitoring the threats, because the bad guys are, and if it's like that old Mad Magazine spy versus spy thing.
Sure.
You ratchet something up, they ratchet the other thing, back and forth, and you get this dialectic.
Right.
And so it's not an easy thing to deal with.
Yeah. Okay. So this has just made me think a little bit as we're talking that there almost needs, well, need might be the wrong word, but it's making me think of this idea of like a police, some sort of like neutral party that could help keep people safe in this space. I don't know if people ever talk about the idea of like I don't know if it's private mercenary to keep people safe or their data online, or if there's any conversations ever about like a public police force or something to sort of like protect people's data, because that amount of information in order to make this run seems like you need to grease the wheels. People have to be willing to share it to make this IoT continue to work and grow and expand.
Yeah, I don't think there's ever going to be a single solution to it, and instead what we need is a collaborative approach.
Okay.
And it's going to include the police, it's going to include the military, it's going to include, and one of the things, incidentally, is this really is a military issue, because 85% of the critical infrastructure, power plants, water plants, chemical treatment plants, you name it, in the United States, 85% of those are in private hands. And so we are extremely vulnerable if those things go unprotected. And so we need both those companies that own them,
Yeah.
and then everybody else doing. And one of the interesting things is there's also a role for, the white hat or ethical hackers in there. There was a frightening and very interesting story in Wired, I think it was in 2016, with video to go with it, where you saw a guy, reporter, who was driving on an interstate in St. Louis in his Jeep.
Yeah.
And he was in cahoots with these two ethical hackers. And suddenly, he's driving along. The sound in his car, the music system, just starts blaring like crazy. They switch channel to some sort of god-awful thing.
Yeah.
The heat goes on in the middle of the summer. He's roasting. And suddenly, he sees on the information display, because it was through the information display that they actually hacked it, he sees the two guys, and they say, "Hi, how you doing?" And then they kill the ignition. And I'm not quite sure why the guy agreed to do this on an interstate, rather than like a little country lane where there's a little bit less to risk. He made it out alive. It was okay. But boy, was that a graphic illustration of the risk. And it
I
was
think
cool because
that's the nightmare, right?
Yeah.
That's the
Exactly.
nightmare that people have
Yep.
when I have all these things in my house.
Another residential one like that was Philips, the Dutch bulb company, which they were one of the very first to share their API. They were the victim of ethical hackers from Canada and Israel teamed up in Israel, and it was amazing because they were using the latest in technology. They had a drone, and they were able, because the Hue bulbs are organized on a mesh network, they were able to become part of that network. And they had a great sense of irony on this. I loved it. They chose a building where a number of Israeli private and governmental security agencies were located.
Right.
And so late at night, you see this drone. It was very cool footage. It's still available. Late at night, you see this drone take off and then fly parallel to the building. And suddenly, the lights in the building start flashing.
Oh, gosh.
And doing an SOS signal. And within I think hours, they immediately shared the information with Philips, and within a couple hours there was a patch that
Right.
avoided this again. But that was a great illustration. And then the latest thing,
Wait, so this is ethical hacking is that sort of like you're just kind of punked with
They're-
a company
they're
and say
good-
wake up
good
guys.
guy punks,
Yeah.
guy punks,
Right,
and
right.
they largely they get together every year and have big conference and everything, and more corporate America and the government.
What's the
is
name of that
attending them.
conference? Is
Oh gosh, what is that
it
one called?
something? Well,
Is that DEF CON? I can't remember. I
DEF CON,
think it is.
maybe.
Yeah,
Okay.
I think that's it. And all of the big companies and government agencies attend that as well to learn from these guys. But
Right.
and just literally a week before you and I are taping this, there was a Gizmodo article that was great by a woman named Casimir Hill, who's been very much involved in writing about these privacy and security issues, where a lot of what's happened on the privacy and security stuff has been sort of wild allegations of fear mongering and everything. And she and one of her co-workers, very important, was the co-worker at Gizmodo, teamed up where he created software that allowed them to monitor, again on a real-time basis, the data flow from her house to the manufacturers of all the devices. And she just loaded her apartment with every kind of device under the sun.
Right.
And this article was devastating because it showed how much data. And I haven't had a chance to do it, but I'm going to write to her in the next day or so and ask, did any of those product manufacturers whose products you used when you bought it give you, as part of the setup process, an absolutely explicit, plain English, not agate type, but easy to read, non-legalese, easily understood explanation of what data would be collected from you,
Right.
the value to you and the company, and the protections, and give you the option not to opt out of having it collected, but to opt in. I maintain that it has to always be opt in. You can't just make somebody have the responsibility be on them, particularly if you do it in some sort of bizarre, oblique way
Right.
to get out of that collection. This can really work to everybody's advantage.
Right.
But when the more players you have involved, the more complex and the easier it becomes for a bad guy to tap into it. You may remember a couple years ago there was.
Oh, I was just going to ask. So, are there companies that are just kind of like air traffic control for like the data on the Internet of Things, or is it, are places just kind of like creating their? Is the layout of the grid like New York, or is it like Boston as far as like the way this information's
More
traveling?
like Boston.
Okay. All right.
It's still sort of a Wild West kind of thing, and I don't think you want to over-regulate it.
Right.
One of the things that's very dangerous, under Edith Ramirez, who was the FTC commissioner under a chair under Obama, she did a really great thing, I thought, with coming up with standards for protection of information and everything under the IoT, which was performance-based, not prescriptive. The thing is, if you get prescriptive ones where you tell companies exactly what they have to do, with the amazingly rapid progress in technology, that particular standard that you set up yesterday that made sense yesterday is obsolete now because of new developments in the technology. So you don't want to tell them what they have to do. You want to tell them the standards that they have to meet to do this. And Europe is ahead of us on that because the European Union has developed this concept they call privacy by design, where it both bakes it in and then also requires constant reiteration and upgrade in the whole thing. It would be great if we caught up with the Europeans in that regard.
On that.
Yeah.
Okay. All right. Yeah, I was kind of a little bit interested in maybe talking a little bit about how you maybe see trying to shift the mindset, because it seems like maybe the technology's gotten over a hump where it can happen, and now it's a question of somebody in a position of power at a business or a municipal leader agreeing to this, individuals agreeing to this. What do you think it'll take to shift the mindset?
Glad you mentioned municipalities, because that is one of the areas that really has amazing potential, particularly in our general area, not Easton, but looking to the city of Boston and other coastal cities with the whole issue of global warming, that there's this whole new concept of resiliency that we have to design in to the design of the city going forward in order to be able to cope with these issues. So, for example, a lot of the development that's going on in the Innovation District, Seaport right now, they're putting all of the critical functions, the heating, air conditioning, elevator controls and everything, upper floors, they're having the ground floor be higher than normal and also be capable of being flooded.
Just building it in.
Yeah, and so there is this wonderful thing, and now that I've finished with my book, it's one of the things I really want to be focusing my efforts on, because there's a concept called the Things Network, which is now a global movement that started 2 years ago in Amsterdam with 10 guys. And that's it, 10 guys.
Okay.
They had no authority. They had no budget from the city. And they put these, what are called LoRaWAN transmitters
All right. Well, what's that?
on. They're just very low wattage and actually rather low volume data collection devices in key areas throughout the city. And they managed to cover, I've never quite known whether it included the suburban and residential neighborhoods or if they were just talking about downtown. Even if it was just downtown, it'd be a big, big deal. For under $10,000. And then what they did was they threw the thing open to anybody who wanted to use it to come up with novel applications where the data could flow throughout this free network. And one of the ones I thought was so clever, and it's cool because it illustrates how the Things Network could evolve in different ways in different cities, is that in Amsterdam, because of all the canals, they have a problem where you might go out in the morning and find, I know my canal boat was here yesterday. Oh, there it is, down on the bottom of the canal. And it sank overnight. And so now what they do is they put these sensors in the hulls of the canal boats that give them just an early warning when they're starting to take on water in time to mobilize the authorities to save the canal boat. So, you could, anybody, one of my friends thought that applying that locally, that as you may know, the majority of the Back Bay is actually built on wooden pilings. When the Back Bay was filled in the 1850s, that's what they used to do things like Trinity Church, which started to have problems when the Hancock Tower was being built, because it was built on those, and it displaced the water table there. Well, as long as those wooden pilings remain moist, they could go on forever. But if the water table shifts, they could rot out, and you could have real problems. So at any rate, they said, why not put sensors on the wooden pilings?
Are there sensors now on those?
Not that I know of. Yeah.
Okay, this is just like a perspective idea of what might.
So at any rate, that's one of the things. But your other half of the question was about corporations, and there is amazing potential with the Internet of Things for companies. First of all, they can achieve an unprecedented level of efficiency and precision that you just couldn't have in the past, where it depended on a couple of guys shuffling around the plant and taking readings from manual gauges, pressure gauges and temperature gauges and stuff like that, about how the assembly line was working. And of course, the assembly line is a whole bunch of individual discrete devices, many of them from different manufacturers, and you, the manufacturer, have to figure out how to bring all those together in the most efficient way. Well, now, with this sensor data and being real time, you can bring all that together, and there's a concept called M2M, machine to machine. You don't even have to have a human being intervening to fine-tune the relationship between two devices. So the creme de la creme of that is one of my clients, Siemens, the German company, has a plant in Hamburg, Germany, called the Factory of the Future. And it has, every time I tell this statistic, people wonder if I'm making a mistake about it. 99.9985% quality rate. And it's not as if they were making a single product there in, continuous loop stuff. Instead, it's where, ironically, where Siemens makes their sensors that are used in Internet of Things devices to collect this data. And so they have a huge number. I think I remember there's something like 100,000 different devices are made there. And they still manage to have this quality. So that's part of it.
So you're saying, like, by using the Internet of Things in the sense that you're collecting data in terms of how things are being produced and how they're being used, they're making better products that last longer.
Yep. Now, the other thing is, in the past, if you remember back to what I was saying earlier about the collective blindness concept, that once you manufactured whatever it was that you made and you took it to the loading dock, it was so long, we have no idea what happens now. In fact, I would argue that in the past, the information you did get back about the product was probably fatally flawed, because it was, first of all, so hard to collect it, so hard to convey it.
It's like anecdotal.
Yeah, anecdotal stuff. It was all like, hey, I love that thing. That was so cool. That's the best, Framus I've ever bought. And then you get this other thing saying, that Framus that I bought from you was a total disaster, and it just, I did stuff that, boy, I mean, it was, and then it was the smoke, and the other, it was horrible. Well, anyway, totally anecdotal, and it was, it just, whatever information it had was basically worthless, because it was never, it was always after the fact and not collected scientifically. Well, now there's this wonderful concept called the digital twin. And two local companies are really the big leaders in this. One is GE, and the other one is one of my clients, PTC in Needham, where they have something called the digital twin. twin.
Right.
And what I'd recommend to people is go to YouTube, do a search for digital twin, because this is an inherently visual thing.
Okay.
That there's one, for example, for the new model of Maserati, that Maserati was able to, using the software from PTC, they were able to manufacture, no, this was from Siemens actually. They were able to manufacture it in a fraction of the time it normally took to design typically a new car model, particularly something as high-end as a Maserati, be like 3 years. They could do it in 18 months because they had this constant feedback from the data. And in the past, one of the things they'd always do in Detroit was make these clay models, incredibly arduous and costly and time-consuming. Well, now, one of the things is, once it's out there in the field, and literally sometimes it is in the field. John Deere, the tractor company.
So rope us back into this digital twin exactly.
Yeah.
What is?
Yeah. So with say for example with John Deere's tractors.
Okay.
They have they're like laboratories on wheels now, and they have constant data feedback to Caterpillar, and they can actually tell how that individual plow, not plows in general, but that particular one is being used right now, and it allows the farmer, for example, to get real-time data on weather and particularly water level, stuff like that, mash that data up so they can, for example, have much more precision than they ever could before in terms of the amount of fertilizer to put down and when to put it down. Mm-hmm. And they also now can do stuff with absolute precision because they know, like
it's the idea that you're getting so much information about a product and how it's being used that in your lab or in your business, you that's the twin. The twin
exactly. You literally see this wireframe replica of the thing with all the data coming in at the same time. So, for example, you might have put in some feature in the plow, and then you notice that in a whole bunch of cases, the farmers actually aren't using it at all. It's like, but it seemed really cool to us. Uh-huh. So either you have to do a much better job of educating them about the value of it, or maybe the next version we don't put that in anymore.
Right, maybe that was a product
whose time has not come.
Yes. So let me ask you this, because I think data is one of those words that people take for granted a little bit. Oh, I know what data is. Maybe I don't. Maybe we don't. Are there new forms of data that's being collected? As the IoT grows?
Big issue with that is what's called unstructured data. Mm-hmm. It's one thing if it is absolutely consistent, but if it's wild data that is being collected in the field under varying conditions and is constantly, then you have to somehow make sense of it.
Sure, yeah.
And that is really difficult, but the cool thing is that there is now software that allows you to do that. And one of the in the last chapter of my The Future is Smart book coming out in August, that I wrap up with. This is the most speculative aspect of it, but I maintain that one of the things this really might allow us to do is get away from the whole hierarchical and linear organization we've had for companies since the birth of the industrial age. When the first factories were created, aim, shovel, and all, that we had local plug. We had two models for big organizations: the hierarchy of the Catholic Church and the Army, and because they also had very little information. It made sense that you organize things in hierarchical fashion and linear processes where information started out one way and then was passed on later on. Well, now that doesn't make sense anymore because you can all have real-time access to that data. So what I
Right.
visualize...
It's like loops, right? Things
Exactly.
move more
So
in
what I
loops.
visualize is a new circular organization for companies where you have a hub in the middle that is the real-time data. And the critical thing is that unlike in the past where, you'd get it, you'd do your thing with it, then you'd pass it on to me, I'd do my thing. And it's sort of like that old telephone tag game. By the end, it bore no resemblance to the
what
stuff at the beginning.
Right.
That instead, one of the cool things is you can break down the boundaries between different corporate functions, and you can work on that data at the same time. One of my favorite examples, and unfortunately I've never been able to substantiate this, but I remember reading an article in the, I think it was the Christian Science Monitor back in the 70s about a new car, didn't matter who the company was, where they had, the design team got together, they came up with this cool design, everybody loved it. They started production, everybody loved it, people started buying it, everybody loved it.
Yeah.
And then the first owner, first guy who bought one, went in for his 3,000-mile oil change to his local dealer. So the mechanic slides underneath the thing and slides out almost immediately. He says, I don't quite know how to explain this, but I know that an oil change is normally like a $30, in and out thing. This is going to take a couple hours, and I'm going to have to drop the entire engine. And the reason was that none of the people who were involved in this design process was an actual working mechanic who would have to deal with it after it was out there. Mm-hmm. And so they just put the drain plug where they thought it should, be easy to put it, rather than where it could actually be serviceable. Well, if you had this kind of simultaneous interplay, I'm convinced that not only would you avoid that kind of problem, but on a more positive sense, it would unleash an amazing degree of creativity and innovation because there would be your perspective, your background, your interests, even your pain points and everything, and then you'd say something. Right. I'd hear it based on my background, my interests and everything, and I'd say, well, yeah, that's cool, Jason, but what about da-da-da?
Yeah.
And then you'd say, well, okay, I understand, David, but what about blah, blah, blah? And then by the end of the whole process, if you've got everybody at the same table and everybody, you got to make sure that you got ground rules and making sure that it's done collaboratively and everything, right. You would end up with a solution that I don't think could be directly attributable to anybody who was involved because it was a synthesis of everybody's ideas. So that, I think, I call that the circular company, and I think that right. is potentially the most amazing thing about the Internet of Things.
It almost makes me think a little bit about what I've heard of as terms of like agile development and Scrum, and as terms of like a working culture. And it's weird because it almost makes me think of like, that's like almost a two-dimensional form when you're talking about websites and applications, but now it almost feels like it's like a three-dimensional kind of like Scrum to create things.
I don't remember having sent you the draft of my book. That's exactly what I talk about in there. Both of those things.
Oh, really? Okay.
Exactly. No, at PTC's big conference 2 years ago, this is really funny. I had a chance to make a car, literally. Mm-hmm. There's a company called Scrum in Cambridge that does consulting work on the Scrum approach to, basically you limit the scope of what you're doing and then it's iterative and
Right.
chunk it up and all of that. And so as a project during the conference, they had a bunch of volunteers, you know, without any training at all, putting together this rudimentary car. And it was like, oh, okay.
Uh-huh.
I can put that on my resume now.
Yeah.
But you're right. That Scrum
Yeah.
and Agile are in, and it's.
Well, I mean, you're really
time-
talking about transforming
Yeah.
the way that companies
Exactly.
operate.
Exactly. Yeah, and we really, we've done that, and obviously software development is one of the most advanced aspects of the
Yeah, I
economy.
mean, that's the easiest.
And
yeah.
we've proven it in that area. It's time we now have, because of the Internet of Things, we have the tools that allow us to extend that to everything. And in fact, there's a really cool company in Cambridge, or is it Somerville, anyway, that is bringing this down to the shop floor. One of the things that often gets ignored when we talk about all the big corporate,
Yeah.
policies and everything is you're replacing a lot of people with robots, but you're still going to have a lot of people in the assembly line. And this very cool company, whose name escapes me right now, is actually coming up with another thing from the software field, no cost, low cost, where they actually, no code, low code. That's right. That's what it is.
Uh-huh.
No code, low code, where people without any programming experience, by manipulating parts of code, can put together programs that, for example, will give guidance to the guy on the factory floor about how to optimize this stuff. So it actually gives them tools as well, which is really cool.
Mm-hmm. Well, this seems like it would really accelerate sort of like some of these processes.
Oh, yeah.
So
So it's not just the products, it's the processes.
the processes,
as well.
yeah.
Well, actually, one of the things that has come about as a direct result of the Internet of Things is this amazing explosion in the volume of data. I can't even remember what the estimates are, but it's truly overwhelming how much will be collected. And if we had the old paradigm of processing by mainframe computers and all, there's just no way you can do that. It would just, the internet tubes would get clogged with data.
Right.
So one of the things that's come about directly as a result of the IoT is the concept of edge computing, where you actually do a lot of the processing right at the point where the sensor is collecting it. And then, when you think about it, say, for example, if the data you're collecting is about operation of whatever it may be, what you're not interested in the 95, or whatever percent amount of the data that is exactly the same every day.
Right.
You want the exceptions, because those are the things that are actionable and maybe actually in some cases dangerous. So there's no point in passing on that business as usual data to your central hub.
Right. Right.
All you do is pass on the deviations. And then also, if you combine it with the M2M activation, you can actually change the process at the point where it's collected, rather than having to collect the data, send it to some central location, whether it's the cloud or whatever, process it, send it back, and then activate the thing. That would be faster than in the past, but there's no point in doing it when you can actually do all of those processes right at the point of collection.
That's fascinating.
Yeah.
Really interesting stuff. Let's see. As we're kind of pushing things maybe towards a close, are there any other aspects of this you'd like to touch upon?
Well, one of the things that I see really fascinating is you and I can see, the audience can't, but this is a thing I have in the back of my iPhone called the Cardia from AliveCore. And it looks like two little magnets, perhaps, on the back of the thing.
Yeah.
This costs under $100. And if I put 2 fingers on the left one, 2 fingers on the right one, and I've got the software activated, in the space of 30 seconds, I can do an FDA-approved, accurate EKG. And I've actually I recently demonstrated it for a physician. Don't think this is a HIPAA violation to say this, who already knew that he had atrial fibrillation. And when I do one for myself, 'cause I just, I don't have a heart condition, but I just like to show it to people. And every so often I do baseline readings just for myself, see, how it is after exercise or meditation or whatever. Well, anyway, when you do this with somebody who's got atrial fibrillation, it actually, the screen goes kind of crazy and says, you better see a doctor ASAP because you have a serious medical condition. And the thing that's so cool about that is that it's not just as accurate as an inpatient one where, you're lying on your back in a Johnny and they put all of those sensors all over your chest and back. It's, horrific. You can do it right now, and you do it while you're living. So it's cool. You can actually you can annotate it. I did this, after I exercised. I did this after I meditated. And you can send it directly to your doctor. So the doctor, for the first time ever, has an idea about how your real life is like. And we're doing this with more and more things. There was a very exciting thing last week with an IoT or an app for the iPhone called Cardiogram, where they, as part of a study that I'm participating in on heart function, they were able to diagnose with 85% accuracy whether somebody had adult onset diabetes without doing any blood glucose testing, simply because with big data analysis, they have been able, the famous Framingham Heart Study nearby, has found about 2 years ago that there was actually a correlation between, I think it was your heart rate and diabetes. And so this actually confirms that. So it's probably not going to be much longer before that app and the Apple Watch, which is the way it's done, will actually be able to diagnose diabetes. How amazing is that?
That's
so
pretty incredible.
It's so cool.
David, it's been a real pleasure having you in the studio today. Love to have you back. Maybe talk a little bit more about some of these things.
Jason.
Sounds like if I came back next week, you'd have a bunch of new things.
Exactly. It's one of the problems about my book is going to be published August 1st, and I wish I could do revisions to it on July 31st because something is going to happen that day that would change everything.
Well, maybe we can get you to the Ames Free Library for a talk.
Awesome. I'd love that.
As the book comes out.
That'd be great.
That'd be great. So David Stephenson, Stephenson Strategies. Is there a website or a way that people can get in touch?
Strategies, and that's STEPHENSON, and that's where I blog about all this stuff. And really would love to have people view it and to, more important, comment on it.
All right then. This is Jason over at the studio at 50 Oliver. Alexa, show is over.